So the recording has started. Um, let's do a quick recap of what we would have learned in the last class. Can anyone tell me um, what is the IPO chart? What is the IPO chart?
Sir, it's basically a table looking kind of chart to represent the components, which is the input, output, and the process.
Good. That is correct. So the IPO chart is basically a table to represent your input, processing, and output. Now, is it necessary? Do we have to create an IPO chart?
Yes, sir, it's necessary because we need to know directly what our input, output, and what our processing would look like.
Good. So you can look at it that way. If you want to document, or if you want to know exactly what is your input, what is your processing, what is your output, you would create this IPO chart because that's going to help you to see that, to see what are those components there. But realistically, it's actually not mandatory. You can actually jump and go ahead and create your algorithm. But to make creating your algorithm easier, it's going to be beneficial to create this IPO chart. So, we should know by now how to create an IPO chart. 3 columns, and you list the components under each column. Now, what we're going to be starting today is chapter 2, which is how to design an algorithm now. So now we're looking at how to create this algorithm. So from our IPO chart, we are going to create our algorithm. But before we get into that, there's some information that we need to understand, some terms that we need to understand, like what is a variable, what is a constant, what is a statement, what is a loop, what is a subroutine, those kind of keywords, those terms we need to understand before we start creating an algorithm. So let's start with the first paragraph. It says, to help the simplification and development of the programming problem, algorithms can be created as pseudocode or flowchart. So an algorithm, to create an algorithm, you can either create what is called a pseudocode or a flowchart. So the flowchart or the pseudocode are different ways of representing the algorithm. They're not types of algorithm. They're just another way of representing the algorithm. Because, did I save it? An algorithm and a pseudocode and a flowchart, they are actually different. But it's only a slight difference. The algorithm can have more English words. So you can say, go to the shop, buy mangoes, buy pineapple, buy cherry, bring it home, and so on. That could be more of an algorithm. You writing in English words, writing in actual sentences, and saying this is going to happen. So, for example, you can say something like, let me type it out. So the algorithm can be more of, you can say add 2 plus tree and store into total. That could be more of an algorithm. You're writing it in actual English sentence. But so this here is an example of an algorithm. Now a pseudocode has more of rules that you need to follow. It has more of a guideline that you need to follow. And that's what we're going to be learning about. What are these rules? What are these guidelines? This is the more professional standard of creating an algorithm, to follow a pseudocode that has some rules. And we actually did it already. It's having the variable first, that container that's going to store the value, then an equal sign, and you say 2 plus 3. It's the same thing. Add 2 plus 3 and store in the total, and it's the same here also. You add 2 plus 3 and you store it into total. They're both the same, just that they're different ways of representing what you're doing at that step. They're just different ways of expressing what you're doing at that step. Are you guys following?
Yes, sir.
The rest of you, are you here?
Yes, sir.
Yes, sir.
Alright. So we're going to go more into detail about that. So an algorithm now. What is an algorithm? We already learned that an algorithm is actually a step-by-step instruction required to obtain the solution to a problem. So that was in the very first class. We said that the purpose of a program is to solve a problem. But before you create a program, you create an algorithm. Now the algorithm is actually you designing the program. So it has to be the steps that you're going to follow to solve this particular program. So that is why in your algorithm, even in your pseudocode, what you're going to do, you are going to number your steps. So for example, you might say step 1, input first number. Step 2, input second number, because it's 2 numbers we're adding, right? 2 plus 3. Step 3, add first and second number. Step 4, or you can even put it inside of step 3 because it's along the same action is being carried out, and store into total. And then step 4, output total. So each step should be a logical step. You shouldn't combine steps together. So but this one here, it's basically combined because that's what's basically going to happen, because when you add these 2 numbers here, obviously you got to do something with the result. So it's almost close to that action that's being carried out, so we can put it in this step here. But for these 2 here, step 1 and step 2, those are 2 different kind of steps. It's one number and then another number, so you can separate it. They're each their own logical step. Step 1, you input the first number. Step 2, the second number. You add everything together, you store it, and then you output that addition. So each step should be a logical step that leads you towards that solution. So step-by-step instruction that is going to lead you to the solution. Now it must have a set of rules. So this is what I was talking about, that yes, you can write it in such a way that add 2 plus 3 and store the total, write it in your English words and sentences and so on. But to have a more standard way of creating the algorithm, of creating the pseudocode, we would follow a set of rules, a set of guidelines that to create in a more professional manner. It must have a set of rules, must be explicit, it must be clear. It must be clear, and it must have a clear stopping point. So this part here is important to note. It must have a clear stopping point. So at the end of the algorithm now, or the end of the pseudocode, so we can say this is an example of a pseudocode. At the very end of it, we are going to simply put the words stop or end, either one, and that's going to indicate that is the end of our pseudocode. Anything beyond that, if there's anything written at the bottom here, that's not a part of the pseudocode. So the pseudocode must have a clear stopping point. Now you would actually give your pseudocode a title. So you would say something like pseudocode adding 2 numbers. That's a title there, adding 2 numbers. So this title here now is actually what is indicating the start of your pseudocode. So the stop at the end here is indicating the end, and the very beginning, the title, is indicating where your pseudocode is starting from. Give me a second, let me see something. I think I had another document. Yeah, I found it. Alright, I'll bring it up this one. Good. So, going back to our paragraph, your algorithm is going to follow some rules, must be explicit, and what we've learned so far, it must have a clear stopping point. So that stopping point is this indication of stop or end here. Now, it is really used to expand the processing part of the IPO chart. That is really what we're doing in the algorithm. We're expanding upon the processing part, and we're going to use flowcharts, which uses diagrams, or we're going to use a pseudocode, which uses English words, English statements, to represent this algorithm. So let me show you an example of both of them. We gotta go to the next chapter to show you. So this here is an example of a flowchart. If you notice, it's using diagrams. So what does a flowchart use? It uses diagrams in order to represent the steps. Come on, man. It uses diagrams in order to represent that step. So a flowchart uses diagrams. So as you can see in this example here, notice the start is in a particular shape, the input is in another shape, the add number 1, number 2, number 3 is in another shape, the output is in another shape, and the stop is in another shape. They're in diagrams. So that is how you create a flowchart, by using diagrams. Now, how do we create a pseudocode? Well, if you notice here, a pseudocode is similar to the algorithm. It uses English words, it uses English statements. So let's look at an example here. So look at this example. You have pseudocode underscore 5a colon add 3 numbers. This is basically the title. And as I said, this is indicating where you are starting. That's the beginning of your program. And notice you have your instructions here. This is step 1, input number 1. Step 2, input number 2. Step 3, input number 3. Step 4, add number 1, number 2, number 3. Step 5, output result of number 1, number 2, number 3. And notice you have end. That's indicating the end of your pseudocode. So you don't have to worry about everything that's happening here. What you're trying to understand right now is that the pseudocode uses English statements. As you can see here, it's normal English words. You write it. And the flowchart uses diagrams in order to create those instructions, those steps in the to represent each step. Uses diagrams. Are you guys following so far?
Yes, sir.
Yes, sir.
All
Yes,
right.
sir.
So the paragraph continues. So let me see. So this is one point here, that the algorithm, you create a flowchart or a pseudocode. 2, your algorithm is a step-by-step process. 3, your algorithm must have a clear stopping point. And 4, you use diagrams for your flowchart, and you use English words, English statements for your pseudocode. That's 4 points we learned this so far. Next, the algorithm should start with a title. So as I said already, your algorithm is going to have a title and end with the keyword end. So that's the 5th point there. So that's how we know where your algorithm is starting from and where it is ending. The title, so let me use this file here now. So this is my guide that I created to show the layout of a pseudocode. So the title is going to be the first part of your pseudocode, and that is to indicate the start of your pseudocode. And you're going to have the keyword end, or you can actually use the keyword stop. And this is going to indicate the end of the pseudocode. So title indicates the start, and the keyword end or stop is going to indicate the end of your pseudocode. The paragraph continues. Developing a program can be a major undertaking, so good algorithm design is very important. It is not always possible to satisfy all the requirements of a good algorithm completely at the same time. So you won't get everything correct in the first go. So there's nothing wrong with getting it wrong in the first go, but you just keep trying until you get that correct algorithm. Because if you've ever noticed, not all programs are perfect. Not all software is perfect. They all have some bugs inside of them. So that basically means that the person that was creating it didn't create a perfect algorithm. So they would have to go back to that drawing board whenever they find a problem to try to fix it. Now, some problems may be complex and hence require complex solutions. However, there are some general goals in designing algorithms. So these are the goals or the rules that you must follow, guidelines, when you are creating an algorithm. Your first guideline is that the algorithm must be correct. What does it mean when an algorithm is correct? It should accept all inputs. We should know that the word input means to put something into the program, to put something into the algorithm. So like for instance, if the algorithm is to add numbers, our input is going to be to put numbers into the algorithm. So if we're going to be adding numbers, or what cannot be added? What can we not calculate? Question to you guys. What can you not calculate? Text and words. The rest of you agree with that? Can you calculate letters, words? Can you do that? Seems some of you don't know.
Sir, please repeat the question.
Can you calculate letters? A, B, C, D. Can you calculate them? Can you perform mathematical operations on them?
Yes, you can, because algebra is a thing.
So, you can add A and B. And what will you get?
Shall add it.
Huh?
Sir, I was thinking more along the lines of algebra, where they would like give you A and B equals 5, and you'd have to find for A and B or something along the lines of that.
Good, but we're not talking about equations. We're just talking about normal letters. Can you perform calculations on them?
Basically, A, B.
So you get
Same thing I
A,
was thinking.
B. Good. Even still, good. We can reason on that. You get A, B, you get B, A. But what's the point in that? Is there any point in that?
Sir, we ask that question all the time and you still can't answer it, so we don't know.
So, right now, for IT purpose, there is no point to this here. There is no point to adding words, letters, and so on. So, say your program is to add numbers. Your program is to add numbers. That's the purpose of creating the program. Alright, we're not going to get into that, Mikhail. So, the purpose of your program that you're creating right now is to add numbers. Now, for this program, what should a person only enter?
Numbers.
Numbers, good. But what will a person try to enter? Especially you guys, what will you try to enter? Won't you try to enter letters also to see if you're gonna work? You won't try that?
No.
No?
Sure, it depends on my stupidity level on that day.
But some of us would. We would actually try the letters to see if it would actually work. Let me see if the calculator actually accepts letters. No, it doesn't work. So what I'm getting at is that you're going to create a program. You're going to create an algorithm. And it's going to have a requirement for a particular input. For example, to add numbers, the input must be numbers. So to make an algorithm correct now, what it needs to do is accept things that are invalid, things that it should not be accepted in the first place. So we know it should not accept letters. So it shouldn't accept letters. But what we're going to do is still accept it. So if you notice, we are going to accept all input and even invalid input. So invalid meaning ones that we should not accept in the first place, such as letters. But what we're going to do is give a meaningful message. So when the person does something that is wrong, that is how we get a correct program. That's how we get a correct algorithm. We tell them that what they would have done is wrong, that we cannot do that. So for instance, in this situation here, we can accept the number, but when the person enters a letter or person enters a symbol and they press enter, a pop-up message appears and maybe it might say error, we cannot process, we cannot add letters, we cannot add symbols. So that's giving the person a clear understanding that it doesn't matter how many times you put in this letter, it is not going to work. So Unlike this calculator here, whereby every time you press the letter, a person who doesn't know, they might be wondering why isn't the letter appearing. So a good program, maybe it would give you some sort of message, or it might even make a sound. Sometimes some programs make a sound when you try to enter a wrong input. They would give you a sound, and that sound would indicate that you're not entering a correct input. Are you guys following?
Yes, sir.
Can you think of any example like that?
Sure. Excel.
What was that?
Excel.
Excel?
Yes, sir.
Like, give me an example.
Sure, like if you're going to put in a function.
I need a more specific example. Where are you putting this function? You're heading in the right track, but I can't think of one that I can help you out with right now. But that's along the line of what we're talking about right now, because there's some situations in Excel where they might tell you that you can't enter. Oh, good. So that's an example there. Sometime in when you're working in Excel, they are going to tell you that you can't do a particular calculation. I don't even know how to recreate that error message. A pop-up message would basically appear, and they would tell you that you can't carry out this particular operation. 0 divided by 0. No. But even this here is an error message that you get in here, and this is another example also. It's clearly telling you cannot divide by 0 because nothing would result from it. There is no purpose in doing that. But then another example is when you're registering for an account, and sometime when you're registering, when you're typing in the username and the password, don't you get a message telling you that you can't use this particular name, or you can't use this particular character in the password? You ever noticed that?
Yes, sir.
Good. So that there is an example of it being correct. It's accepting the input, it's accepting the word, it's accepting the symbol, but instead of just refreshing the page and not telling you what happened, it's going to simply tell you that the character you entered is invalid. The character you entered is wrong and we won't accept it. So that's what is meant by being correct. Now, the second step or the second guideline is that your algorithm must be simple. Each step of the algorithm should perform one logical step. So, as I mentioned that, I would have mentioned that in this example here, each step must be a logical step. So, you could group all of this into one step. Some persons might group all of this into one step. Input the first number, second number, add them, output. They might group all of that in one step, but that is not correct. That is not the rule that we should follow. The rule is that each logical part, each logical step should be its own step. That's how we make our algorithm simple. The third guideline is that your algorithm must be clear. So the algorithm should be easy to read and understand. So not only should you be able to understand it because you created it, but anyone else who is reading it should be able to understand also. And that is why we would actually follow the more structured method of creating the algorithm, of creating the pseudocode, because this here is a more standard method and persons would understand that more. Well, basically persons who are creating algorithms, who are familiar, they would understand that more compared to reading the actual sentence and trying to comprehend. It's like it's going to be like English now. They're going to have to read your sentence. They will have to read your sentence and try to comprehend now what you're actually saying in that sentence. Whereas this method here now, a person can simply look at it and be able to tell that your add was on the right hand, your store was on the left hand, because of that structured manner. So making your algorithm clear so that any person can be able to read it, that should be a goal for creating your algorithm. You guys follow me so far?
Yes, sir.
Yes, sir.
Anyone with any questions? If you have any questions at any point in time, feel free to ask them. Alright, so your fourth guideline. Your algorithm should be precise. Precise meaning that the algorithm should present the solution steps precisely and concisely without referring to low-level programming code. So, precise meaning that it actually relates to being clear, put it in simple words, following the structured manner so that any person can be able to understand it. They look at it, they read it, and it's clear to them. That's what is meant by precise. But being precise also means to not use low-level programming code. And this is an important point to take note of. Any of you know what that term means? Low-level programming code? Alright, seems not. So, another question. All of the information, all of the data that is on your computer, what state are they in? This is third form work. All information, all the software, all the program, everything that you're seeing on the screen right now, what state are they in on the computer? Or let me rephrase the question. Does your computer see what you are seeing? Does your computer see all of these words, these lines, these letters? Do they see that? Or do they see something else? Does the computer see something else?
Sir, the computer sees something else.
Can you repeat?
Sir, the computer sees something else.
Which would be?
Binary something.
Very good, that is it. So this is important to remember. You would have learned this in third form. Whatever your computer is doing, anything that your computer is doing, it does it in binary. It does it in ones and zeros. It's constantly dealing with ones and zeros. Everything that you're seeing right now, me drawing this, all of these words, all of these programs, everything that you're seeing on the screen right now, that is not what your computer is seeing. All your computer is seeing is ones and zeros, and it takes those ones and zeros and converts it into what you are currently seeing. So that is what they are referring to here. that when you're creating this algorithm, we do not refer to low level code, or we do not refer to binary. So we don't mention any binary code. We don't mention anything that relates to the computer. How you write your algorithm is basically how you would speak on a daily basis. You use normal English words. Now, you guys clear on that?
Yes, sir.
Awesome.
I have a diagram here. I'm going to send it in the WhatsApp group. So, this diagram here, very important to take note of. When it comes to programming languages, we should know what's a programming language. A language that you use to create a program. Now we have types of programming language. We have low level language, we have high level language, and we have assembly language. We have three of them: low level, assembly, and high level. And this is the order they are in: low level, assembly, high level. So high level is at the top, so high at the top, low level, that's at the bottom. Low level is what is called machine code. So if you look at the very end, that is the binary that your computer is going to see. The assembly code now is more of a code. If you notice, LDA 181. So they tried to move away from binary. They were trying to move away from binary, but to try to add some English words. But if you notice, this one says ADD, so that's actually add. And LDA is actually load. And STO is actually store. But because you can't look at it and determine that from the very first look, that's why it's not so much in use today. So we moved on to the high level language. The high level language is what any person can be able to read and understand. That is the programs that we use today. We call them high level language because they are created, they are designed using words that we can understand. For example, you can have words like hours, salary, pay rate, input, output, print, and so on. Those words, you clearly understand what they mean, what they're referring to. So, high level language is what you understand, what you can read. And that means the computer does not understand it. So what actually happens is that the high level language has to be converted into low level language, because low level language is only what your computer understands. Your computer only understands low level language. Are we following?
Yes, sir.
Good. I just sent the image to the group. So, once again, low level language, also called machine code, is binary. That is all your computer sees. That's all your computer understands. Your computer does not understand the word one. It does not understand the word description. Does not understand the word example. It only sees the binary form of it. Now, we do not understand binary. If any of you were to try to translate or to tell me what is this code of binary here, you would not be able to tell me, because you won't be able to know what is that binary unless you use some sort of converter or some sort of translator. So what we did, we created a version of programming called the high level program so that you can understand that. So when you're going to create a program now, You create it using high-level language, and then the system converts it into low-level language so that the computer can understand it. So that's what they're referring to here. When you create your algorithm now, you do not use any binary, you do not use any assembly language in your description. You only use English words. Now your fifth point, your algorithm must be easy to implement. The algorithm should be relatively easy to translate into the programming language. It should be that simple. When you create this algorithm, it should be so easy to translate. It's like if you are creating the program in the algorithm. That's how easy it should be. So that you're creating this algorithm in such a way that all you have to do is translate this particular step. So let's look at the example. So for example, in this pseudocode here, this algorithm, the very first step says to input first number. So in your program now, all you have to do for that step is write exactly the code that will allow you to input a number. And you're done there with the first step. You move on to the second step now. Input second number. You write the code now that is going to allow you to input another number. And you keep going like that step by step. So that is how you're going to create your algorithm. Clear enough so that you know how to translate it into your program. And then your final step, your final guideline into creating your algorithm is to be efficient. The algorithm should enable the program code to produce results quickly, depending on the problem size, and not waste any memory or time. So it shouldn't take too long to give you the result. I know some of you can be annoyed. Everyone is annoyed when you try to do something with a program and it takes long to carry out that particular action. Like for instance, if I want to draw something on the screen and say it takes like a second or two for the ink to appear on the screen, that would make anyone frustrated. That would make anyone annoyed. So similarly, even if you're going to use a calculator, you shouldn't have to wait 1 second, 2 seconds, 3 seconds to get back your result. You want it right away, as fast as possible. And that is how you should design your algorithm. Now, in order for you to get results as quick as possible, you actually have to make your code. Why did I put the R? You actually have to make your code short. So you write as small of code as possible. You don't write too much steps. You try to reduce the amount of steps that you have in your algorithm. So for example, going back to this pseudocode here, instead of elaborating more and all of this here and adding more unnecessary steps, we keep it simple. We add only the steps that are necessary to actually make the algorithm work, to actually make the program work. So you do that, you make your program efficient by lessening the number of codes that you're going to have, lessening the number of steps. Because running a program is actually like reading the program. So say for instance, I'm going to zoom out. Say for instance, this entire chapter, the first page and the second page, say that is a program. We're just using this example, that's a program there. So what that means, if you're going to run this program, it has to read from the very first word at the top here, going through this column, coming over to this column here, reading through, keep reading everything, and then the program runs. So it has to read all the words here, and then the program runs. Now, if you were to cut it short and see this here, this one page alone, is all the codes that you would have written. Then when the program is going to run now, it's going to read this here, read the first column, then the second column, and then it stops at the bottom here, and the program runs faster than before because it doesn't have to spend time reading what's at the bottom here. So that's what makes it more efficient when you use smaller number of codes. Now obviously in all situations you won't be able to reduce the number of codes because you will need a certain number of codes or a certain number of steps in order to carry out a certain action. But what you're going to do is try to not put too many unnecessary steps in your program. You try to make everything as simple as possible. Alright, so that is the 6 guidelines, the 6 goals that you're going to follow to make an effective algorithm. Are you guys following in all that?
Yes, sir.
Anyone, any questions? No questions? Alright, let's continue. So now that you have been introduced to algorithms, you should become familiar with some other terminologies. These apply to both pseudocode and flowchart. So it doesn't matter which you're creating. The following terms apply to both flowchart and pseudocode. So our next terms are variables and constants. Any of you ever heard that term before? Oh, you actually have. In maths, what is a variable and what is a constant? Variable is the unknown. And what's a constant? Nobody? Yeah, sure, yeah, I got C-Sec next year. What's a constant in maths? Or there is no such term as constant in maths?
Sir, the variable is basically the letters, and the constant is just the values like numbers.
Good. So, out of the two in maths, which would you say changes?
Sir, the constants.
The constants change? Okay. And does any remain the same?
Sir, how do you mean if they remain the same?
Do they remain the same value? Which remain the same value? They keep the same value all the time.
Sir, variables.
Huh?
The variables.
They would keep the value?
Yes, sir.
Alright. I guess it depends on how you look at it. Either way. So, in IT, we have the same terms. And I would like to think it functions the same way as in maths. Variable, whenever you hear the word variable, think of the word vary. Meaning, it changes. And whenever you hear the word constant, what does the word constant mean?
To remain.
To remain. So it's going to be the same. So variable is going to vary, so it changes, and constant is going to remain the same. So that's your keywords there. So let's explain how data is usually stored when it is input. So remember, in our program we have to input data, and when we input data it has to be stored. Where do we store it? We store it in containers called variables. A variable or constant is an area or space in memory that holds data that a program might use or manipulate. So if we go back to our pseudocode, when we were inputting our first number and when we were inputting our second number, they had to be stored in somewhere in order for it to be processed. Where is it going to be stored? It is going to be stored in what is called a variable. So in this case here, you would actually say input first underscore number, because you would give this as the name of the variable. So you would say input and you would say what is the name of the variable. And if you notice, in most cases you would try to name the variable. You can actually name it X, and this could actually be named Y. Nothing's wrong. But what you would try to do is to name the variable exactly what is going to be stored inside of it. So for example, first underscore number and second underscore number, so that we know that it is exactly what is being stored in that particular variable. So whenever we input data, it's going to be stored in a variable. That's our first point there. And we need to name that variable based on what it is being stored. That way it's easier for us to know what's the purpose of that variable. Now a variable can contain text or numerical values. So basically you can type in words into the variable, you can type in numbers into the variable, and it is going to store it. Unlike in maths, where the variable is only going to store a number, is only going to be equal to a number. In this situation here, a variable can equal to another word. So for example, we can have a variable called first underscore name, and that is going to be my name inside of it. So the variable on the left hand side, first underscore name, which is first name variable, and another word is being stored inside of it. So a variable can contain words, letters, symbols, or numerical values. Now what is a constant? A constant is actually a type of variable. It functions the same way as a variable. It is going to store a letter, it's going to store a word, it's going to store a number, whatever the case may be. But the key point is that the value does not change. Throughout the program, throughout the algorithm, that value does not change. Only the variable changes. So for example, we have certain values that will remain the same throughout the program. For example, pi. Pi is always 3.14. VAT for a country is always going to remain the same, a certain percentage. A person's year of birth, that is always going to remain the same. What other values do we have that you're going to use, but it does not change?
First alphabet.
Can you repeat? I didn't hear that clearly.
First letter of the alphabet.
The first letter of the alphabet. Good. So we know those won't change. Letters of the alphabet. What else? What in calculations do not change? Do we have anything when you're calculating dollar notes? What values? Values. We're more looking for values. What values do we have that does not change? It might change, like maybe every 2, 5, 1 year, couple months, but it doesn't change as often. Alright, let me give you an example. We have discount. So when you're given a discount, that usually is a specific percentage. It might last for a couple months, couple weeks, but it's a specific value that would not change until it's necessary to be changed. Can you think of anything else? The pass grade for a particular course, for a particular subject, that's going to be a constant. You might say that the pass grade is 50%, the pass grade is 55%. So when a student gets a grade now, you compare that grade, which is going to be a variable, because remember, students' grades are going to change. Different students have different grades, and you compare it to that one value, that one constant, that one pass grade, 55%, 50%. So the key takeaway right now is that when you input into a program, into an algorithm, it has to be stored somewhere. Where is it going to be stored? It is going to be stored in a variable. Now a variable is going to store a value, is going to store a text, is going to store a letter, but we have another type of variable called a constant, which is going to store one value throughout the program. It does not change. You guys clearing up?
Yes, sir.
Now, the values in a variable can change throughout the program. So the variable can change throughout the program. So, for example, going back to this algorithm here, you run the program one time and you input one number, and that's going to be that particular number. Now if you run the program again, you might input another number, so the variable changes. You run the program a third time and you input a different number, or even if it's the same number, but more so a different number, the variable, the value inside of it is going to change. Now examples of variable names are number and total. Each variable is given a name so that you can assign values such as numbers or text to them and refer to them later to read the values. Variables typically store values of a given type. Now before we get into the type, of variable, from database, if anyone can remember, why do I have an underscore between first and number?
What's that? As we can put space.
Right, because we should not put space. We actually can put space, but we should not, because when you put space, it is going to be treated as two different words. Obviously, it is two different words, but remember, the program now, it's not thinking in the way we are thinking. We are thinking that this is actually one word. We're actually thinking that this refers to one thing. So first number, we're thinking that that's referring to one thing. But the program now, it doesn't know that we are thinking that way. So when you put a space, it's going to think it's two completely different entities. So in order for us to make it one name, we have to put an underscore. If you need to put an underscore, you can put a period, or you can put no space at all and make the first word a capital letter. Whichever you choose, just ensure you use that same pattern throughout the algorithm, throughout the program. So either no space, period, or underscore. In some situations, hyphens work also. Now, each variable has a type. So what I want you to do is to think of a variable. Can I write properly? Think of a variable as a container, or more so, think of it as a bowl. Now, do we have different types of bowls? Do we have different types of container? Let me use the word container. Do we have different types of containers? I'm talking about the literal containers that you have in your home. Do we have different types of containers?
Yes, sir.
Yeah. You got butter bowl, you got basin, you got basket, you got tub, you got bucket. So those are different containers. And depending on what you want to fetch, what you want to carry to maybe from the sink to a table, or from inside your house to outside your house, you can use a different type of container. So if you want to carry if you want to eat food, obviously you're going to use a plate instead of a bucket. Anybody ever eat from a bucket? No? I think one of you could try it. Yeah, if you want to eat, you eat from a plate. You won't eat from a bucket. So that's the container you're going to use. So similarly, each variable, think of it as being a container. And now similarly, we have different types of variables that are going to store different types of data. So depending on what we want to store in the variable, that is the type of variable we are going to use. So our very first type of variable is called a integer. Now integer is kind of related to real. So just that they have a slight difference. An integer is a whole number. So whether it's positive, whether it's negative, that is an integer. But an integer does not have decimal places. That is where the real comes into play. The real allows you to have fractions, which basically gives you decimal numbers, positive or negative. So if you only want whole numbers to be stored, you're going to use an integer. But at any point in time, you need a number with a decimal place. You are going to use a real data type. Now, so that is the two data type that relates to numbers. Now we have two data types here that relates to letters. We have character and we have string. Now as the word character indicates, a character refers to a single character, a single letter. So a character data type only stores one single letter, whereas a string is going to store a collection of letters. So if you ever want to store a particular word, you are going to use a string. If you want to store a sentence, a phrase, you are going to use a string data type. But if you're going to store only one single character, or one single letter, one single symbol, you are going to use a character data type. Now our final data type is going to be a Boolean data type. So for those of you in science, you might know this term Boolean. Boolean basically refers to having only two values. When something only has two positions. So it's either true or false, nothing in between, nothing else. It's either yes or no, no maybe. You're either a male or you're not a male. Either a female or you're not a female. So there's only two states. So that is what is meant by Boolean. So if you're gonna accept the input, some sort of question, something as an input, and it only has two states, you would use what is called a Boolean data type. Are you guys following?
Yes, sir.
Now lastly, as I said already, your name should be meaningful. You should use meaningful variable names in your program so that if you or someone else needs to review the logic of the data being processed, then the variables are easy to remember and understand. So that's why you would actually try to name the variable based on what they are doing, what they are storing. So that any person, even you yourself, maybe 10 years from now, you are reading your program again, and just looking at the variable, you can tell what is the purpose of it. So that's what makes a variable having a meaningful name. Alright. I think that's enough information for one day. Any questions so far?
No, sir.
Alright, to recap what we've looked at so far, we looked at an algorithm. We should know that an algorithm is a step-by-step precise process leading you to a solution. Now, you create an algorithm by either creating a pseudocode or a flowchart. Now, what is a pseudocode? A pseudocode is written in English statements. What is a flowchart? A flowchart is written using diagrams. Remember, your flowchart, your pseudocode, your algorithm must have a clear stopping point. It must have the keyword end or stop to indicate that is the end, and your title indicates the beginning of that algorithm, of that pseudocode, that flowchart. These are the guidelines to ensure your algorithm is basically perfect. It must be correct, simple, clear, precise, easy to understand, and efficient. And then lastly, we looked at what is a variable. It changes, it stores values, but it can change throughout the program. The constant is going to store a value, but that value does not change. And then we looked at the different types of variables and constants we can have: integer, real, character, string, and Boolean. Any questions before we close?
No, sir.
Questions going once, questions going twice. So to no questions. Alright, what I want you guys to do, practice, use your SBA, because you still have to do it for your SBA. Go to the programming part of your SBA, so this part here, and read through this part here, this first part, problem solving, the very first step, and try to design your IPO chart. That should have been your homework for last week. So using this instruction here, design your IPO chart. So basically, as we go through our our chapters, you can actually start working on the various parts of your program SBA. So we haven't started designing algorithm as yet. So create your IPO chart, and so once you've perfected creating the IPO chart, when we get into the next chapter of designing an algorithm, you're going to be ready to create your own pseudocode for your SBA. Alright, so that's your homework for next week. If no questions, that is it for today's class. Enjoy the rest of the day. See you tomorrow.